quieter.
Yeah, the rumbling from the vibration. Yeah. All right. Hopefully you can tell that the sound has diminished quite a bit, and we can pump it all out and diminish the sound, but we're not going to. So let me return the air. If I can remember how to do this.
Twist and then pull up.
See the air coming back in. Oh, that's so cool.
All right. We should have done that in the hallway where it echoes.
Yeah. All right. Is it recording now or is it still yellow? Thank you for that technical help there.
Of course.
All right. All right, let's finish up this mod. Remember how I'm just doing like 3 days on a mod? The problem types that we've seen so far have been finding the velocity in a given temperature. Remember that formula with frequency equals velocity over lambda? We had that one, and then we've had the Doppler effect. And I believe and now we added this calculation with the thunder and lightning. So that's the only things that you'll be tested on in this mod. And I have one more thing to discuss with you. So would you like your quiz tomorrow? It's not much notice. Or Friday, which is prom. Or Monday, which is awful after a weekend. Those are your three.
I say Friday.
Three beautiful choices.
I say Friday. I mean, as long as it's not long, it doesn't
It's not.
take into our Fat Friday time. I'm okay
No,
with
it's not long.
Yeah, I'd say Friday.
Okay. All right. Well, then I will finish up today. I'll review a little bit on
Tomorrow.
Thursday,
You ever
and
give us a
then
worksheet
we'll
for
quiz on Friday. I think that's the best day too. Sorry.
Did you ever give us like a worksheet for this?
Yeah, I will.
Okay.
All right, I'll give you that tomorrow in preparation for that quiz. All right. The rest of our discussion today then, a little bit of theory about, we've talked a lot about sound, so we really should talk a little bit about light. And turns out it kind of dovetails into what we just did here, because sound has a medium. And I said to you earlier, can I yell at you in outer space? And the answer was no, there's no medium. Can light travel through space? Yes, I mean, there it is. There's the sunlight. There's the sunlight out there. Light traveled all the way from the sun to here. And I want to know, what is the medium for light waves? Every wave has to have a medium, so what is the medium for light? Because it even travels in outer space. All right, well, there's been several waves of thought. There's been several camps of thought on this, and here is what we've come up with. First of all, the question that we debate even to this day, is light really a wave? Because it does travel through space where there is nothing. So let's see if it acts like a wave, or maybe it doesn't. What this guy did, he took a light source, so he's shining light at a screen, and he put a little hole in the screen. So if you would do that as well on your paper. So when the light comes toward it, we'll draw it like with waves lengths, like these are the crests that I'm drawing. So the crest and then the trough, the crest and then the trough. So the pink is the crest. When it reaches the screen that has a hole in it, something interesting happens to these waves, and it goes like this. They come out of the hole like this. And we call that diffraction. Which doesn't really prove it's a wave yet, but look what does. Then he put up another screen in back of the first one with two holes in it. So go ahead and sketch the crests approaching the first screen with one hole, Then the bended or diffracted waves coming out of the first hole toward the second screen. You have that down? You see your beautiful screens, your holy screens.
Ah.
All right, I see most of your holy screens. All right, so when you get here, and it starts dealing with the two openings here, probably doesn't surprise you. It goes like this, out of the one opening, and like this, out of the other opening. So what should we do but put up another screen, but no holes in it this time. We're done with those holy screens. All right, this is where we decide on this last screen whether light is a wave or not. Because this wave, if this wave comes, the wave from the one opening hits the wave from the other opening, they both meet. Do you know what happens when two waves meet like that? It's called interference. And when they meet at the same, say these are two crests that are meeting. So like it's sort of like if you know, like if you're in a boat and your boat is making waves, and then another boat comes along and it makes waves. Do you know what happens when those two waves meet, crest to crest? Anyone? It's higher, it's twice as high. So, and they've seen water that's perfectly still, and a couple of boats go by and it's like crazy. All right, well this is the same thing happening if light is a wave. So, over here, if light is a wave, and these spots travel over here, these crests where it's a double crest, we should get some bright spots on our screen, shouldn't we? Now, if light is a wave and these are troughs, we should get some really dark spots on our screen. Say that's a dark spot. And then, if there's some crests that meet troughs, so you have a crest meeting a trough, and they cancel one another, and at that point, there's no wave. So there should be some blank spots as well. So, guess what happened? If light is a wave, and this crest to crest thing is really happening, we should have bands of dark and light across that last screen. Guess what we have? We have bands of dark and light across that last screen. We do. So this says that light is a wave. Like we were suspecting, but what is the medium? Well, the best thing that we've come up with, and this is probably still debatable. Will it show up if I write over here, Annabella?
Yeah.
All right, here comes a light wave. And what we are saying that there are two things waving at us. And this is the electric force. So now we're saying what is really oscillating for a light wave is electric force in one direction, and I'm not very good at drawing 3D pictures here. So here's the electric force in a wave, the light wave, and then perpendicular to it. So I don't know how to draw this perpendicular to. So this is coming out straight toward you, this pink part. That is the magnetic force. So your book has a pretty good picture of it. So there's actually two things that we believe are waving at the same time at right angles to one another. And the yellow is an electric force, and perpendicular coming out of the board toward you, which I have trouble drawing, is the magnetic force. So we call this electromagnetic force. That is what is the medium for light waves. That is the medium. So the question is, what is the medium? The answer is electromagnetic force is the thing that is oscillating for the light wave. So we were pretty happy with that idea, and we held with that for a long time. But enter Albert Einstein. So he liked to ripple the waters, so to speak. So he noticed something that didn't jive with this theory. So he was good at what time are we done here?
15.
10:15, good. I can explain Einstein in 5 minutes, so. All right, what he did is he noticed that if you have a piece of metal, metal,